Dear students, this is a presentation on physics for grade 9. We are going to study energy, heat and temperature, which is the unit P3 of the grade 9 syllabus. So first of all, we are going to recall what was learned at grade 8 level. So these are some of the topics that were covered at grade 8 level. I hope you remember some of them. We talked about forms of energy, work done, kinetic energy, gravitational potential energy, interchange of kinetic and potential energy, and finally, power. So we have studied the forms of energy, which are heat, light, sound, electrical, chemical, kinetic, and gravitational potential energy. We studied about work done, which is obtained by multiplying the force and the distance traveled by the body. Kinetic energy, which is the energy possessed by moving bodies. We have also studied about gravitational potential energy, which is the energy possessed by a body that is kept above the ground. We have also studied the interchange of kinetic energy and potential energy, that is, how potential energy can be converted into kinetic energy. And finally, we studied about power, that is, the work done in each second. We can also call it the work done per unit time. So what is work done? As you can see in the picture, the person is pushing on the table. So the person is applying a force, and the table moves in the direction of the force. It moves through a certain distance. So if we take the force, we multiply it by the distance moved by the body in the direction of the force, we get the work done. The unit of work done is same as energy. It is the joule. Let us see an example. A football player kicks a ball with a force of 500 newtons while his foot is in contact with the ball. It moves a distance of 0.1 meter. Calculate the work done by the football player. So we know that work done is equal to force times distance. So it will be equal to 500 multiplied by 0.1, which gives 50 joules. So the work done is 500 times 0.1 is equal to 50 joules. Now let us see what is kinetic energy. We have an object of mass m, which is moving with a speed v. Then its kinetic energy is calculated using the formula. Kinetic energy is equal to half times the mass times the speed squared. So consider the truck, which is having a mass m and which is moving with a velocity v. So we get its kinetic energy as half mv squared. Now consider the example given. A player serves a volleyball. with a mass of 0.2 kilograms. The ball leaves her hand with a speed of 30 meters per second. Calculate the kinetic energy of the volleyball. So we know the mass of the ball is 0.2 kilogram. The speed of the volleyball is 30 meters per second. Now using kinetic energy of the volleyball is equal to half mv squared. We get half times 0.2 times 30 times 30, which gives 0.1 times 900, which in turn gives 90 joules. So the kinetic energy of the volleyball is 90 joules. Now, if you look at the truck, will the kinetic energy of the truck be more than the volleyball? Think about it. Our next topic is the gravitational potential energy. This is the energy possessed by an object when it is lifted from the ground. So the gravitational potential energy is equal to the mass of the body times the acceleration due to gravity times the height through which the object has been raised. So EP is equal to mgh, which is equal to the weight multiplied by the height for something that is rising above the ground. We need to know the weight and the height through which it has raised. Consider the example given. A 36 kilogram girl walks to the top of the stairs that are 2 meters high. How much gravitational potential energy does the girl gain? So considering the formula, potential energy is equal to mass times g times height. So it is equal to 36 times 10 times 2. So it is equal to 360 times 2, which is equal to 720. So the gravitational potential energy gained by the girl is 720 joules. What would happen if the girl is going to move still higher, say 3 meters high on the stairs? Will the gravitational potential energy increase, decrease, or remain the same? Now let us see what happens when we are going to roll a marble down the ramp. So what is the form of energy possessed by the marble at the top of the ramp? Since it is at the top of the ramp and certainly above the ground, it has gravitational potential energy. When it is released from the top of the ramp, it starts rolling down. When it reaches at the bottom, it moves away at a high speed. So how the energy at the top has been converted or transformed? So the gravitational potential energy at the top of the ramp is converted into kinetic energy as the ball comes down the ramp. So we can say simply, the gravitational potential energy has been transformed into kinetic energy. Now imagine we take the marble and roll it towards the ramp. What energy conversion would we expect? So while the marble is moving towards the ramp, it has kinetic energy, and as it starts moving upwards on the ramp, it will have gravitational potential energy. So the energy conversion is kinetic energy into gravitational potential energy. So this is a very simple example of how energy can be transformed from one form to another. Now let us learn about power. Power is actually defined as the rate of doing work, or power is equal to work done over time taken. We can also call it the work done per unit time. Let us take the example of a crane. A crane is used to lift 200 kilograms load from the ground to a height of 20 meters in 10 seconds. Calculate the power exerted by the crane. So, the mass is 200 kilograms, the height is 20 meters, which gives the work done as the weight multiplied by height, or simply work done is equal to mgh, which gives 200 multiplied by 10 multiplied by 20. It gives 40,000 joules. Now the time taken is 10 seconds. So the power is equal to work done divided by time taken, which is equal to 40,000 divided by 10, and this gives 4,000 watts. The unit of power is watt. So let us summarize. We have talked about work done, which is obtained by force multiplied by distance. We have talked about kinetic energy, which is given by half times mass times velocity squared. We have talked about the gravitational potential energy, which is obtained by mass times acceleration due to gravity times height, or weight times height. And we have also talked about power, which is the rate of doing work, or simply the work done per unit time. Thank you for your attention. We are going to have more PowerPoint presentations on the topics that are left. Thank you.